Hi, everybody. Welcome to our series of the Federated Analytics webinar. Today, we're going to talk about Bunny and the Rabbitverse, which is a lightweight open source tooling ecosystem built for real world needs. We're going to give a few minutes until more people can join the webinar. But meanwhile, I'm just going to talk a little bit about the housekeeping. So make sure you know that the webinar today is being recorded, and this recording will be available for in our website, so you can watch the video again and other people can watch it offline at your own pace. So at the end of the webinar, we'll have a Q&A session. So make sure if you have any questions, please type them in the chat and we'll pick it up in the end. We abide by the HDR UK values, and for Red follow the link of our website. And I just hope you enjoy the webinar today. Just our agenda for today, just hello and welcome from me. I'm Graziella Figueiredo, Associate Professor in Health Data Science from the University of Nottingham, but I'm also the training lead in Federated Analytics. That's why I'm hosting the webinars. We're going to have some highlights of the Federated Analytics program delivered by Tim Beck today. He's Associate Professor in Federated Systems and Bioinformatics. And we'll have the talk for Bunny and the Rabbitverse by Andy Rae. We'll finalize it by the Q&A sessions. And if you have also any suggestions of how we can improve the webinar, or if you're interested in participating, just let us know. Just a few announcements, as the Federated program is interested in both creating digital infrastructures that will allow us to conduct federated analytics in healthcare. We also have an educational piece, and we are very interested at creating a PhD student register of students who are interested or researching anything related to federated analytics or federated learning. So if you are a potential PhD student, or if you work with people interested in joining us and contributing to the Federated Analytics program in any ways, please contact me on my email. I'm going to put together this register, and the idea is to have seminars and also have meetings where we get together to exchange ideas on federated analytics. So if you're interested, just let me know and we'll start talking and organize events for more directed at PhD student research. So the other thing that we've decided to modify around the webinars is now we've defined 4 educational streams that we'll be addressing throughout the year with the webinars, but also in the website, you will find the webinars organized by these streams. We are interested in privacy and security, existing platforms, tools and frameworks for federated analytics, applications in industry or in academia, and the federated analytics ecosystem, which is us informing everybody interested in the work that we're doing about our progress. And the reason is because we want to invite the community to be able to collaborate with us. So if you're interested in our ideas, please stay in touch. Tim will talk a little bit more about the program now and about the progress so far we've achieved. There will be some information about how to contact us and get involved. So if you're also interested in delivering a talk on the webinars or contributing to our educational work streams, it doesn't matter if you're a PhD student, early career researcher, or if you work in industry or senior academic, we welcome all talks around federated analytics. So I'm just going to now pass over to Tim, and he's going to give us a few highlights of the Federated Analytics program. Thank you very much.
Thank you, Graziella. So hopefully you can see my slides. So hello, everyone. So my name is Tim Beck, and as Graziella mentioned, the HDR UK Federated Analytics Programme is hosting this webinar series. So I'm going to spend a few minutes to share a few highlights from the programme so far. So the Federated Analytics Programme is assembling and integrating existing infrastructure and standards to support easier and reproducible federated analytics within trusted research environments, or TREs. So the first couple of slides describes the federation-ready TRE services that we have developed. So the first is the FedA software stack pilot. So this is an open source stack that offers safely portable and deployable TRE neutral analytics. This is along with metadata collection and exchange to support 5-saves processing. So this really has allowed us to explore what is possible. So it builds on standards from the Global Alliance for Genomics and Health, GA4GH, specifically the task and workflow execution services. It also builds on RO Crate by using a 5-saves RO Crate, which is a new way of packaging up digital objects that maps onto the 5-saves principles. So our minimal viable product has a download guide and documentation, which is available from our website. Although we've found that this combination and assembly of multiple tools, although it is powerful and it allows us to demonstrate what is possible, it is also complicated for TREs to install. So in collaboration with NHS Secure Data Environments, or SDEs, a simpler version called Bunny has been created. And Bunny is open source software. It supports the HDR UK cohort discovery tool, but it also supports wider federation. Relay is an associated application for enabling federated networks in cohort discovery. And together they form a starter kit for introducing federation readiness into TREs. So acknowledging that the federation is a new concept to many TREs, Bunny offers a low barrier to entry. And so we see this mechanism as a way to take TREs through a stage of early adoption and then towards full federated capabilities. So this software is being used by NHS, SDEs and others. I'm not going to say any more about this because our speaker today, Andy, will be picking up this story in a few minutes. So we want to ensure that what we are developing in the Federated Analytics Programme is interoperable with national and international frameworks. So members of the programme have contributed to influential reference documents to ensure that they align to the needs of the UK health community. So the DARE UK Federated Architecture Blueprint defines a standardised method for securely moving data between UK TREs and also for sending analytics from one TRE to another. EOSGen Trust is forming a similar blueprint, this time for TREs across Europe, which is based on the DARE UK blueprint with federated analytics based on what has been developed by the HDR UK Federated Analytics Programme team. The Federated Analytics Programme is pushing the boundaries of current knowledge in this area through 4 PhD projects. So these projects are focusing on different aspects of federated analytics and federated learning, including one project here that is investigating the acceptability of federated analytics across TREs from a digital transformation and a business perspective. So this is an interesting topic since many of the established TREs have to undergo change management and digital transformation to adjust to Federation and become Federation ready. So we will spotlight the work of these students and other, as Graziella mentioned, other PhD students and early career researchers working on federated analytics in some future webinars. So the Federated Analytics Programme managed the joint HDR UK and Elixir UK hackathon. So this was hosted in Nottingham in February. So for anyone who doesn't know what Elixir is, it is the European research infrastructure for life sciences data. And we worked with the UK node of Elixir to bring together technologists and researchers from healthcare and life sciences to work together on some shared challenges. So this was a popular in-person event. It was happy to say it was oversubscribed, and we saw the development of novel technical solutions that certainly, according to the feedback we've received, wouldn't have happened without this event. So there were projects covering a range of scientific fields, including AI and data linking and text analytics. There are also projects around fair data management, image analysis, and the development of code lists. So there are a few ways that you can find out more about the Federated Analytics Program. So we have a mailing list that will keep you up to date with announcements. So scanning the QR code on the left there will take you to the sign-up page. There is a monthly technical roadmap review and drop-in session. So the Federated Analytics Program team are advocates of open development. So this is a collaborative approach to creating software in which the process is transparent, the process is inclusive, and it's accessible to a broad community. So the drop-in is open to all, so anyone can come along and meet the team. You can find out more about the technical roadmap, and of course, there's an opportunity to ask questions. So the connection details for these sessions are on the website and are sent to the mailing list. And then finally, we have GitHub discussions for technical questions between the drop-in sessions. Scanning the QR code on the right there will take you to the discussions page. So that's it for my update from the program. I'll just leave these QR codes up for a moment longer before handing over to Andy.
Thank you very much, Tim. So now we're going to have the main talk from Andy Rae. Just quick introduction to Andy. So Andy is a research software engineer, and he works at the University of Nottingham in the Center for Health Informatics, but he's a big advocate of open source and software for real-world impact. And at the moment, Andy Rae works across academia, hospitals, and national programs, such as Federated Analytics, leading research software development teams for healthcare and impact. Thanks very much for joining us, Rae. It's a pleasure, Andy Rae. It's a pleasure to have you here with us.
Thanks, Graziella, and thanks, Tim. Thanks. I'm a long-time listener, so thanks for having me, and thanks to HDR as well. As Graziella said, my name's Andy Rae. I'm a software engineer within the Centre for Health Informatics at the University of Nottingham. I also have an honorary role inside Nottingham University Hospitals as head of research software within research and innovation. In the next, I have about 20 minutes, I think. So my promise to you is by the end of this, you will understand what Bunny is, what the hype is about. But much more interesting, our approach to open source software, software adoption, community building, some of our challenges throughout the space, and kind of the value that we feel that can be locked within Federation through these kind of open source approaches as well. So a little bit about our team. Centre for Health Informatics we're a group within the University of Nottingham School of Medicine. There's about 15 engineers, software engineers, technologists, data scientists, all sorts of people who work with programs such as HDR Federated Analytics, the NHS Secure Data Environment Programme through Data for R&D, DARE UK Evolution, EOSC and Trust. But we're all trying to kind of help turn technical ideas, often around federation, data data standards, open source software, into actual kind of practical change in the health space. My background is I've been working within this team for a few years now, but beyond that, actually, I'm not really a software engineer. I worked in the film industry in the UK for about a decade. So my background is often in communications and storytelling, and I try to see that way. So today I'm going to tell you the story of Bunny. So for those unfamiliar, the NHS SDE program for data R&D allocated about £100 million for regional secure data environments all around the country. I work with this one. I'm not sure if you can see my cursor, but it's hovering around the East Midlands. That's part of my role at the University of Nottingham University Hospitals. But as you can imagine, SDEs have many requirements for £100 million, and one of which is cohort discovery. Specifically, a requirement for SDEs to be part of the HDR gateway tool. Cohort Discovery Search Tool, which is actually embedded within the Health Data Research or HDR Innovation Gateway. What this actually is, it's about enabling researchers to make specific searches on data sets around the UK, but without ever seeing the underlying data. So a simple ask, how many smokers aged under the age of 30? Each data set will return a summary level, anonymous answers to those queries. A count, effectively back. Now, this enables it to be really powerful across many data sets. A researcher can find out what summary data is available without contacting people or having to do discovery through what I call email query, not having to go to a hospital and ask them, and for that email to be passed up a chain across clinicians and administrators to find out what data do we have. Now, this model is great. It's compliant with the 5 safes. A safe person is the is the researcher who's doing the querying, for example. But this enables data custodians to kind of be part of research at a very early level and discover these cohorts while still retaining control over who has access to the data. Within that, they can do, for example, controls such as obfuscation, suppressing low numbers and rounding numbers to ensure that results can be representative of the data, but won't actually ever expose something that it shouldn't. So this is quite a simple model, and this exists. So in order to do this, you need a tool deployed next to where the data lives to fetch, execute, return queries on a data set. In the past, this has been a proprietary tool, which is a great tool, but not always suitable for every data partner. And that tool, all it's doing is querying an OMOP database. Now, OMOP from Odyssey is a data standard for healthcare data. It is a way of effectively just creating all health data to make it look the same. That's a simple model. So all we're doing really is simply querying a standard data model, which it sounds really simple, and it mostly is. And this is very much a solved problem technically. And in some sense, this is federation. I don't really call it federated analytics, but mostly federated access. Each data controller is able to have their data accessed through outbound requests while still preserving protection of their data. As I say, it's really simple and really powerful. This enables data partners all over the UK to be part of a data network. Because it's simple, this is often a great opportunity to make something much, much more complicated, which is often the engineering approach. That leads me to Hutch. Tim touched on it briefly, but Hutch is a toolset built by our team, developed through the Federated Analytics program, the DARE UK programs, and it enables federation in many ways and kind of cohort discovery, but also federated analytics and going towards federated learning as well. Hutch is really cool. It can do many things and it can do cohort discovery. So a few of the SDEs last summer were looking very much at Hutch because it enabled this federation, but also because it's open source, which is great. It's great for me, great for our team. But some of them began to kind of get these stacks installed. We got it running, but quickly became clear that using Hutch or the Terrific stack for cohort discovery purely, it's just too complex. It was completely overkill and unnecessary. And we couldn't really advocate for what we were doing. And, I was effectively a customer thinking of the East Midlands secure data environment. So we had a choice whether we could kind of spend months wrestling with that kind of complexity or build something simpler, something people could actually use now and solve the problem for them now. And so our team had a look at this. We have experience in this space, working in cohort discovery within Federation, with building great software. And so last autumn, we built Bunny. You can click the link, or probably not. You can go to bunny.health. But Bunny is open source. It's easy to deploy. It's under an MIT license. There's a link to GitHub on that page as well. But the key here is it wasn't just something we built, but something people needed, something we had expertise to deliver, and something we could build really fast. Now, as I say, Bunny was built last autumn. I think we're about 6 or 7 months in effectively, and I can show you how far we've come in those 6 and 7 months. Bunny at a technical level is secure by design. It runs behind your firewall with only safe outbound data requests only to approved endpoints. It will execute only approved queries and will only ever return aggregate results. It has fast query resolution, so it resolves those kind of really complex cohort discovery queries against OMOP databases in seconds. It's very fast and faster than alternatives. A data partner we actually recently deployed with has a database of about 40 million people, which it was able to handle in seconds. We believe in letting the database do the work. Have integrated disclosure control. It will apply built-in result masking to support kind of responsible data sharing. So that's low number suppression and rounding. And these are kind of easily configurable to ensure and meet governance requirements. And it's open source, always. With transparent, inspectable, auditable code you can kind of trust and deploy confidently. And effectively, Bunny is the same. It sits next to the data. It securely fetches, executes queries against that OMOP database. This all reflects our original governance model. So the change to use these tools is no different than it ever was. Additionally, we also have a further federated option, Relay. Now, Hutch Relay sits in between middleware, acting as middleware effectively, but it enables federation. So being deployed in a central space in the middle here, it can create a federated network of bunnies. It will aggregate the results from its network of bunnies and kind of enables further disclosure control of query results as well at its central node. It simplifies data governance is used in that sense. And it will return aggregated results upstream back to the cohort discovery tools, even if a node is unavailable or fails. So it's effectively self-healing as a network. Now, similarly to Bunny, Relay container images are easy and available for kind of deployment in any environment. But Relay can request queries from any compatible upstream task API, such as the Hutch cohort discovery tool, or even Relay itself. And this is kind of an interesting point for us, which enables us to do slightly more complex architectures. So in this, we have green gateways, blue relays, red bunnies, and orange databases. Now, this is kind of fun, but it's not just for fun. This is kind of important if there are various levels of governance models up and down a stream, such as at a country or a state level, or for example, NHS ICB level or regional levels, such as an NHS SDE. We're able to offer disclosure control right down a network, but also expand quickly to add new databases and bring them online, and also enable organizations to offer many databases internally as well by simply creating more infrastructure. And we're kind of solving federation here through infrastructure instead of more code, which is always nice. It's not quite a tree, this architecture. I do like to call these kind of deployments bunnies in a tree, mostly so I can just show bunnies in a tree, which is the cutest thing in the world. Bunny is the perfect name for us. It's small, lightweight, but also we can say both tools are gateway compatible, both tools are relay compatible, both tools are open source MIT, they have a lightweight install. We published the container images for ease of deployment, and both tools have disclosure control baked in, which is configurable as well. So this is great. So we built a thing. So what? What Bunny does, I think, is often the least interesting thing about Bunny. but we have an open source product. We invite contributions from community across universities, the NHS, as well as commercial organizations. But I've been making open source software actually for a decade, despite being in the film industry. So I publish my code to GitHub. For the most part, people don't care. And I think everyone, as a software engineer, mostly when you publish things to GitHub and you make it open source, it doesn't go anywhere, and that's okay. This one has gone somewhere, which is really nice for us. And it's worked. So from our original network we were kind of testing this with 2 or 3 SDEs originally. At this point, the magic thing about bunnies is they multiply. So from our group of 3, 9 regional SDs will now be using it so far. So that's about 80% of the network are going to be adopting it as their solution for connecting with cohort discovery. So it's really exciting. But it's not just about that usage for us. It's also about the contribution. So far, I think 5 of those SDs have made contributions to the code base. 2 commercial companies as well. So thanks to Answer Digital and Fitfile for contributing to open source software, pushing their changes upstream as well. But all of these organizations and all of our partners kind of setting requirements, owning the tool, shaping it, and contributing in some way. And it's not really just about the tool or what it does for us, but about community, this approach, the ownership, the buy-in, the collaboration, and open source software within the NHS SDEs, which is a nice win. For us, so my colleague pointed me to this diagram the other day. To understand the adoption cycle, this is from Rae and Gren-Peter. We have a cycle from policy to infrastructure to training and tools to communities and incentives, making it required, making it possible, making it easy, normative, rewarding, and required again. And this is how we've kind of adopted Bunny and enabled Bunny to be adopted in all organizations. So NHS England, of course, made the policy. They made it required that a tool would have to be used. We've made it possible through building Bunny, through building up this infrastructure, the code itself to enable that. But beyond that, we've made it easy. And I'll talk through that a little bit more now about how we've made it easy and how we build that community to make it normative and made it rewarding as well through incentives as well. So I'll talk through a little bit more about our technical approach to this. Because I did say this was a technical webinar, so we could get a little bit more technical, which is nice. So we're open source, so we have to have a security model. We leverage GitHub a lot in doing all of this, but it's really nice to enable this. So we have contributions made by pull requests. They're all, of course, reviewed by our team internally. 1 or 2 people have to approve the code before it's actually merged into the code base. But we also leverage things like code scanning using GitHub CodeQL analysis, which is enabled on the repository. So that's going to automatically scan every contribution and automatically identify security vulnerabilities, but also just coding issues and quality. We have a security policy for vulnerability reporting as well. The unofficial policy within that is if you get a high-level bug bounty, you will get a lint chocolate bunny. But we also have secret scanning, code scanning, type security, code quality, formatting, linting, all that good stuff as well. And you might kind of ask yourself why, like, what's the point? Why am I mentioning this? It's what happens when you get grilled by security teams like we have, people who are suspicious of open source software and aren't really convinced when I start quoting foundational ideas from the Linux kernel and open source can be secure. People like certainty, people like process, and so we give it to them. And that kind of, going back to that adoption cycle, all of this is about making it possible, making it easy for them. And we really build on this certainty and process, such as testing. We have a test suite for Bunny, which happens in continuous integration. So we have unit integration, end-to-end testing, and meaningful coverage across that. So on the right, you can see a coverage report, which I think is from our latest PR. So for those unfamiliar, a coverage describes the percent of the code that is covered by tests. So you can see the green number at the top here, I hope, that it's 88%. Not great, but not bad. We're anticipating it to be higher soon. For us, making this public, making this open is like an incentive. We need to, make sure that we're not just doing this in terms of coverage vanity. but making it meaningful, making sure that the most important parts of the code are covered and tested well. For example, people particularly like confidence around disclosure control, as you can imagine. And a data partner often needs confidence that if there are code changes, that disclosure control still works, such as if my disclosure control rounds a number to 10, what if we break it? Well, we have dozens of tests, both unit, integration, and end-to-end tests specifically for that area. We've really leveraged end-to-end tests to kind of run the whole code base, queries right the way down to ensure it behaves consistently every way. And of course, if the tests fail, well, the code won't be merged until it does. But this really enables us to create certainty and for our adoption to make it easy as well. And we're all about making it easy. So much so we talk about image publishing. So we publish all Bunny images to a GitHub container registry. So it enables our data partners and anyone who wants to use Bunny really easy to make for them to deploy it. I'll talk a little bit more about that. But how those images are built, well, again, we use GitHub Actions. This is a repeatable, transparent build process. Each dependency from that build process is pinned to a Git hash. So you can see this action on the right. This is the steps. So we check out the repo and we set up Camus, set up Docker build, right? These are just actions, but you can see at the end of this action where we say set up Docker build action at this. And this is a Git hash. And for those of people who are familiar with GitHub Actions and these Git hashes, this really creates certainty that every time we build the image, it uses that exact code. It's not good enough just to use version numbers. You have to use the Git hashes to be traced back and ensure that this is reproducible every time and ensure that your supply chain is not flexible effectively. But it ensures this automation kind of each build is consistent and it could be traced back to its source code and also build instructions. Every Bunny image being published to our registry, but images are also pinned to specific workflow hashes as well, which kind of prevents any unauthorized modifications and ensures that only verified builds are used. So we kind of plan for the worst case that if anyone has access to the worst possible access to something in our supply chain, well, they probably can't do anything, which is really, really nice to reflect on. And all these pinning mechanisms help maintain security by ensuring that the exact version of the code is reviewed and tested is also the one that is deployed. So as I say, we published our container registries. So I always see that as having a level of empathy for my infrastructure team within NUH, for example, and making their lives easier. We also respect semantic versioning, and we offer plenty of samples, so enabling infrastructure people to be able to spin up Bunny quite quickly. We offer sample compose files, also Kubernetes manifests and Helm charts for really quick installs, should you be interested. And also flexibility, because we're open source, organizations can actually just build their own images if they feel as though they need to. And also, I mean, they can fork the code and create contributions in that way should they want to, and make local changes that's specific for their infrastructure. And this is all about making it easy in order to make it adoptable, right? So much so that we really think about our supply chain as well. The base image and all our dependencies are, of course, reviewed for security updates. Bunny is built with Python, so we have a pyproject.toml, for those familiar, to outline all our dependencies, compliant with, is it PEP 518.621? I'm the kind of person who knows PEPs, unfortunately. We also leverage GitHub's dependency review action. And I always bring this up because I think it's a really underutilized GitHub action, but it's used to detect vulnerable dependencies before they're introduced into the code base. So when you make a pull request, it will scan the dependencies and check, is there anything wrong with it, to prevent anyone from bringing in insecure dependencies into the code base. It's really nice. And of course, we also leverage Dependabot to automatically scan dependencies, ensuring security vulnerabilities are identified and patched. And we publish our updates and release notes, and we do kind of regular releases through our release process. Additionally, we publish a software bill of materials, which is particularly nice for security teams. It kind of provides visibility and dependency into our dependencies and supply chains as well. This is the kind of thing you need to think about should you want to be deploying inside organizations a lot of the time. As I said, all of this is about making it easy. It's creating the infrastructure, creating the environment for people to succeed with the tool. But it does enable us to create certainty that Bunny is secure, which is really nice. And that's it. And effectively, once people have this certainty, they began to contribute, which is really nice. So we kind of quickly hurried together and created contribution policies. So we have a brief contribution policy to enable people to contribute from outside our organization. And this is about making it normative. And we have, every now and then, we have a dev bunny fluffle. Fluffle is the collective noun for multiple bunnies. This is actually true. But this is about making it kind of normative and making our community easy to work with. And implementing a contribution policy is often maybe the last thing people think of, but it's something that really enables things to fly and makes it rewarding. So often when organizations will contribute, we try and expedite and make things fast, and hopefully they can get their code and changes that they care about into the code base and making it released, and makes it rewarding for them that they've contributed something upstream and they've seen their changes come in. It benefits the whole wider network, which is really nice. So we really think about this kind of life cycle of adoption, making it required, of course, by NHS England, making it rewarding, normative, easy, and possible. So that's my kind of a technical approach to that kind of stuff. But I think this is what we're seeing across our open source strategy as a whole. The Rabbitverse has many products. We don't just have Bunny and Relay, but things like you might have heard about Carrot and Lettuce, which also we pursue the same strategy of open source and building community around them, which is really nice. That's nearly me. My final notes: Bunny, secure by design, fast query resolution, open source, and integrated disclosure control. So I think that's my 20 minutes or so. Questions? So a quick testament to those in our team who contributed, our collaborators as well, who have contributed to code, to requirements, security policies, penetration testing, documentation, branding, logo ideas, and all those other things as well. It really makes a difference, and just holding us to account in order to make our software as good as it could be. And it's worked. So yeah, thanks very much.
Thanks very much, Andy. I have quite a few questions for you, but there's one first question that I think goes for Tim. So Becca was wondering what is the rationale for adoption of standards from the genomics community for federated analytics in healthcare?
Okay, thank you, Gratz, and thank you, Becca, for the question. So yeah, many of the products from GA4GH were developed for genomics data use cases, but have then since been extended for clinical and phenotypic data use cases. For example, Beacon version 1 supports genomic data discovery. The most recent version, Beacon version 2, supports phenoclinical data discovery. Other GA4GH products are agnostic to the data domain. For example, TES and WES. So this is the Task Execution Service, Workflow Execution Service, which are used in the Federated Analytics program. So these products help researchers run analysis tasks and workflows in compute environments. So regardless of the underlying data model. So there are specific technical considerations for implementing all of these products within TREs. For example, considering the air gap. So for example, TREs are not accessible from the internet, whereas a lot of the genomics data sets and data resources are. So the FEDA program is building on these standards. So instead of developing from scratch, we're building on the GA4GH standards to make them usable within TREs for federated analytics.
Thank you, Tim. Andy, now there are quite a few questions for you. I think perhaps you might want to share your slides again, because there are a few questions around the architecture. So when you show the architecture of Bunny and Relay, so I think that there's a question from Alex Knight, and he's asking in the architecture diagram, I assume it's for the relay where you have the multiple bunnies. There are multiple paths from OMOP CDMs to the source of the query. How do you avoid duplication of data, double counting things? I think it's actually in the next slide when you show the tree, because you can see there are multiple bunnies from and to relay.
Absolutely. So this is a great question, Alex, and it's something we think a lot about. I mean, in some sense, the short answer is you can't. But the longer answer is sometimes that's a good thing. The purpose of cohort discovery is effectively to give high level answers and high level numbers to be able to describe that data sets underneath. So there is sometimes creating noise in that network isn't always a bad thing when it comes to disclosure and control. So sometimes people see this as often as a feature, but our governance model and our kind of that we work within for this does mean that we can't often hold state at every level of the diagram, and the database is where the truth is. So by creating more complex architectures, you do begin to hide the truth effectively and create and in some places double count. It is the reality of it. I think in order to achieve different approach within cohort discovery, you would need completely different architecture and change the way and thinking how it's done as well. So from data partners we talk to, is something I always bring up that if you create many layers of relays, you are effectively creating uncertainty through that. Many actually see that as a feature, but also this is something that can be mitigated effectively by ensuring or talking to the data partners underneath them about their level of disclosure control and how they've configured it as well. If everyone configures 10 all the way up, then that kind of creates a lot of uncertainty. But if they don't, then that can be reduced and made more useful, if you will.
There's a related question, Andy, from Jenny. For cohort discovery for conditions where you have very low number of patients, how does the deduplication of the same patient appearing in multiple sites will occur within Bunny?
Yeah, so a simple example might be this, that again, for very small populations and such that if that number is less than the low number suppression can be configured, and what that low number suppression is completely configurable up to the data partner. For the most part, people often go with 5 or 10 for the most part. So it kind of enables queries below that threshold to just not be returned at all, or be returned 0. So in that deduping, again, unless you have a different approach to your architecture, a different approach to cohort discovery, then that's the only way you can really solve that problem in deduplication. We're not moving any patient data around. We're literally asking the database to do all the work for us here.
Andy, I have a question because I work a lot with big data technologies. So when you have here these multiple data controllers, let's say they come from different TREs or SDEs, a parallel in big data technologies, we would have multiple nodes where we want to retrieve the data or the information about the data. So we have the concept of heartbeat. So we know that a node is alive or a node is enable us to do searches. One of the concerns that might come about is when you're doing cohort discovery is reproducibility of the results if you submit the same query to multiple TREs within the tree of within the network. Do you have a mechanism similar to heartbeats so you understand which TREs are alive and able to provide a response. So you have these checks.
Mhm.
Mm.
So
Would
that is in the API spec by the HDR cohort discovery tool. They do have a heartbeat mechanism in which we can check whether bunnies are alive. We've not implemented it yet. It is on our roadmap that we effectively will at some point, but it does enable more certainty about whether those bunnies are alive and still part of the network or not. But even if they aren't, Relay, for example, doesn't mind. It will still try and send them for the bunnies, but it won't if that bunny is no longer responding, Relay will still work with the rest of its network. It's absolutely fine as well.
And what are the current mechanisms for disclosure control and bunny and hutch? So is it a privacy preserving method, technology? So for example, differential privacy, manual statistical disclosure control, similar to data shield. So how does it work?
Yeah, so the queries, but because we're using the database, we do two things effectively to ensure disclosure control, which is low number suppression. So any queries with a count that underneath that number will not be returned or will return zero, and also enabling rounding. So queries responses to those responses can be rounded to again a configurable number. So, for example, a number of 14 might be rounded to 20 or 10 or 100 even, depending on what that level is. We do have a more advanced idea of differential privacy and enabling adding noise effectively to results as something we've continually spoken about as a team, and we think it will come. It will make it into our roadmap, I think, quite soon, because we do think there's another layer that will be useful in order to add noise as well. But this is all automated and it's all done through checking through the tool itself.
So Ed is wondering what kind of queries are supported at the moment. Can one use many of the existing OMOP CDMR packages? Maintain some of them. So he's just saying that he maintains some of these packages. So could it be integrated with Bunny?
That's interesting. So Bunny relies on a very specific data format that is created by the cohort discovery tool upstream. So there's an API format that we effectively adhere to as a data standard, if you will. So if your tools are compatible with that data standard, of which it's open, so we talk about what that standard is in our documentation, then yes, is the short answer to that. Bunny itself is just a Python container built for running those queries. So it really doesn't matter how that query was built as long as it exists. So we offer this API fetching as well. But another interesting thing to Bunny, and I've not really mentioned it here today, but we also have a command line interface, which enables those queries to be run directly at a user level, at a kind of data partner level, which enables Bunny to be part of wider, more interesting infrastructure such as Traffics and other tools as well, so that can actually run it as workflows as well. So that might be an angle in which you could kind of be compatible with other tooling, and that'd be really interesting. I'd like to pick that up.
Brilliant. So Pipin is asking if you could elaborate a little bit more on the monitoring capabilities of Bunny. So for example, is there a built-in way for data partners to track and analyze the executed queries, identify frequently used resource-intensive queries? Would it need to be set up externally by the data partner or something like that?
No, absolutely. That's a great question. So, Bunny itself will not do that work for you. We believe in building one thing and do it well, and this is why these tools are often effective. And honestly, building more monitoring and building logging and the kind of capturing into Bunny doesn't kind of make sense. Nowadays, these problems are solved by other infrastructures and great tooling out there. So we can log out the SQL that runs on our database. That is an option the user can do. But there are other ways you could just actually monitor your databases in order to do that. So that's how I set up my bunnies. I have a bunch of tools actually monitoring the bunnies. So we use things like low-key in Kubernetes and Grafana to actually monitor our bunnies and monitor the logs, monitor the databases as well through Prometheus and Postgres to actually check those performance questions, but also what's not working and do that as well. So that's kind of how we see Bunny. We've not spoken much about that. We do have a series of recommendations in our documentation. We would like to kind of expand that of like what does it look like to not just have bunnies, but to monitor them and to enable them to troubleshoot in a much better way as well. So it's some recommendations as well we can make, but we in our team are really just beginning to understand that as well. But that's how we've been handling it. We don't see it as the job of Bunny, but many people are great at writing that infrastructure, so we leverage that instead.
And Andy, is this tool to be used by UK collaborators only, or it could be used for international projects such as DigiCore?
I don't know what DigiCore is, but short answer is yes. So we're happy for this to be used. This is completely MIT open source software. We work with international partners. So there is a Bunny running in Australia, for example. We're talking to a team in Singapore as well. So yeah, we're more than happy for Bunny to be used internationally. And it's not just limited to the HDR cohort discovery tool in that sense.
And for those interested in collaborating and getting access to Bunny, what's the best way?
Yeah, your call action is, of course, you can go to bunny.health and get it running and having a look through documentation, but you can always drop our team an email. I'm sure our details are provided somewhere in this panel.
And there's one final question is, can Relay and Bunny do federated analysis after the cohort discovery?
That's a great question, and I think it comes back to Tim's kind of original pitch at the very beginning of what we've enabled is a step forward with any federation with open source software with Bunny, and this has enabled data partners to do their first step rather than jumping to advanced data federated analytics or federated learning even. They've managed several organizations to actually do federated access, right? But using these approach. So can Bunny be used for kind of do more? Maybe like you can twist it and you can turn it and you can do that. But actually, I think there are other tools out there, such as the software that we're developing through the Federated Analytics program, which provide a much more coherent wrapper for federated analytics. Bunny can be used inside them, but I don't think Bunny on its own directly is going to enable that. It comes back to my idea of not my idea, but our approach of we do one thing well instead of building the software that will take over the world.
Okay, I think we've reached the end of our questions. For the audience, if you have any further questions, keep posting them in the chat and we'll answer them to you, and also send us an email if you have any further questions. We'll be happy to follow up. Andy, thanks very much for the talk. It's been great. It's really nice to see how much the team has achieved, and there's loads of interest within the community. Thanks very much, team, for giving us the highlights of the Federated Analytics. And thanks the audience for participating and joining us in this webinar. As I said before, if you're interested in joining the community, just follow our website and our links and get in touch, and we'll be happy to make you part of the community. Thank you very much for joining today, and have a good rest of the day. Bye.